Alright. Test out. Test out my melodies. Why do I always go for Limp Bizkit? Alright, so. Ad started playing. Just want to check something really quickly. That's not how you spell float. Float 4. 1. Just want to see what it does here. Okay, cool. What happened with relay?
You unlocked that one.
Alright.
Essentially, pull someone out of the and then like,
Why did it do
I will
that?
like if this.
I
would imagine. It's like
yeah, you unlocked all the characters somehow.
indie game. An indie game system. Because like if he's able to grab something.
So let's start off.
Yeah, I think this is
I feel like that pushes doors.
Hey guys, who's here for the shader workshop?
I am.
Cool. All right. So today, and I would suggest pulling out your laptop because I actually did want to try and like do this one more interactive. So I'm gonna give you a little bit of time to pull your laptops out, just so that you can do this. Also, door. Come on, time is money. Beer Thursday, please. Like to do some stuff, see some people. This stuff should work regardless of what version of Unity you're on. And a lot of it's being pulled from Cat-like coding. Haha, surprise. You know what's great? I actually have...
Can we use the text?
I actually have Cat-like coding pulled up on my computer right now in case I make some dumb error. Which I did actually make a dumb error when I was trying to set up this lesson. So if suddenly I do a hard left on something, I'm very sorry about that. But the general idea about how this stuff should work is what I care more about, and that's not really all that difficult. Also, before we start, I'd like to remember exactly what a BRDF is. BRDF. Oh god, there's only one thing. BRDF. BRDFG. Roblox profiles. Bidirectional reflectance function. Cool. Alright. Yeah, don't worry about it. No, this TV's bad though. Like, it's.
No, it's math.
Don't worry about it. It'll be okay. Everything will be okay. Everything will be okay.
It's what?
Math.
Oh, is that normal? Why is that normal?
Don't worry about it. Don't worry about it. Everything will be okay.
Don't worry.
Don't be worried about it. Gosh dang it.
I'm terrified. Oh, I thought that was Sean.
Forget your
Okay. So, y'all good to start? Or? Alright, cool. So let's begin. Alright. So, I want everyone to look at this table for 1 second. Exactly 1 second. This cursed ass table. If you don't have a cursed ass table in front of you, look around for a cursed ass, very reflective table. And what you'll see is, you know, reflections from the light and kind of, you know, this table reacts to light. Right now, with all the shaders we have done, they have had 0 light interactivity. And, you know, if we kind of look at, this isn't actually the standard shader, this is what I'll be teaching today, but if you look at most games nowadays, they kind of fall into this thing called PBR, or physically based rendering. Physically based rendering essentially is trying to mimic how light interacts with the object. So games that are lit and kind of are like, hey, you know, when Mario jumps in the, yeah, they're lit, bro. When Mario jumps in the water and he climbs out, he's kind of like weird and lighter and brighter and more reflective. And that's because we're trying to mimic what happens in the real world. When we essentially jump in water, you know, the water reflects the light. And the reason for this is that essentially when, oh gosh, I wish I had like a whiteboard or something to explain this because I do have a whiteboard. It's too big though. Where's the
Draw it on MS Paint so
all right.
viewers can see.
MS Paint? MS Paint?
Oh, you just RMS.
MS Paint.
The best.
Perfect.
The best drawing application.
So let's say we have a sphere here, and let's say a light ray hits it. So, what?
Make it yellow.
No, okay. Let's say a light ray hits this sphere.
It's actually kind of hard.
Gosh dang it. Let's say a light ray hits the sphere.
Code black.
Oscar, please. Are you actually? I will adjust again if you need me to. But if you're trolling me, I'm
Keep on
gonna.
going.
Okay. When light hits an object in the real world, essentially what we're seeing is the reflected color. So let's just assume that's an arrow. And the thing is that this happens on a very, very, very small scale. So essentially, if you were to say have like something that's very like, oh cool. Let's say we have this. Say if we have, I wish that was black, whatever. If we hit light here, it's gonna kind of bounce everywhere and like go all over the place, and it's not gonna look that shiny because essentially all of the light that was there has bounced around in like weird ways. If you look at like a brick wall is really bumpy and it's kind of reflecting light all over the place, and it gives it a really matte look. When you see matte in the real world, essentially what it is that light is bouncing so erratically from the surface that it can't create a very defined specular highlight. However, with this sphere, and say with water, and if you notice like people who get sweaty, or bald people even, their skin essentially fills in all of the cracks. Like their sweat and the water fills in all of the weird little diffuse like refraction points. So what ends up happening is you get this really clean bounce off from the light, which creates what's called a specular highlight, which is this bright point right here. And this is kind of the basis for a lot of modern video games and how modern video games do lighting, especially on body lighting. And there's other things we can use this for, like, hey, if you're in a driving game and your tires go through like maybe a puddle, maybe you want those tires to kind of look a little bit wet. So what you can do is you can kind of say like, well, the water filled in all of the cracks and crevices in the tire and essentially made it brighter. Or not brighter so much as the light was more concentrated and reflected. And in real life, things do obey these laws. If you ever looked at the floor in a lab and noticed that when you move, kind of the bright spots move with it, it's because essentially your eyes are, think about this very simplistically, your eyes are shooting a beam into the floor and bouncing off, and essentially that bounce off is eventually going to hit like a specular highlight. And that kind of follows with where you're looking from and where your perception is. So yeah, a lot of that is a lot of heavy content, and if I move this, you'll notice like the specular highlight kind of moves to do that, because we're essentially saying like, hey, from me, shoot a ray, and if the ray bounces off this object and hits the sun, that's the inverse of what really happens, but it's still what happens. That's how ray tracing actually works. This is all very roundabout and a long way of saying this shit's important, and this shit is like high key needed for realistic rendering, and even in non-realistic rendering and non-photorealistic rendering, having a specular highlight can really sell someone on an effect or on a look. So what we're going to do is we're essentially going to go through the math to get us there. Full disclosure, and I think that this math is super important, but essentially if you want your shader to interact cleanly with lighting in Unity, you really should be using a surface shader instead of handwriting your own, unless you really want to go through like 10 hours of cat-like coding tutorials, which is what I did. But I think this also gives us some important context for the math that you need for shaders, and I wanted to go through this and show everyone this. So let's start by saying, hey, we got this Blinn Phong unlit demo, and let's just start from the beginning. So unlit, where are you? Unlit, Blinn Phong demo. So, hey, that's a pretty standard looking ass shader, we got our texture going, you know, all the good stuff. And all right, so let's start off by deleting the stuff that I don't care about. So multi-compile fog, fog chords, and fog chords here, and apply the fog.
Wait, which type of shader is this?
This is, so actually we're using an unlit. So we're going to create shader, unlit shader. Standard surface shader is if you wanted to, I would recommend using standard surface shader for what we're about to do in most cases. However, I think that this particular problem and these particular demos are really good for understanding some of the 3D math that shaders make use of all the time, as well as understanding kind of masking principles and how things interact inside of Unity's shader code. So we're not doing compute shaders, not unless someone wants me to bust out my awesome fire particle effect. So, you know, we're looking through this and we say like, all right, you know.
You deleted everything with fog in it?
Yeah. You don't need to. It's just not really going to affect us right now, so I usually get rid of it just to clear up some space. And yeah, so tell me when everyone's kind of...
The only thing you deleted?
Yeah, I only deleted the fog
How
stuff.
did you do the create thing?
I went to the project window, right-click, create, shader, unlit shader.
Create, share,
All right, everyone good? Cool. So the first thing we're going to want to do is we're going to want to think about it from the perspective of the sphere. So does anyone know, I can't really spoil it without doing this, but so say we, you know what, let's go into wireframe. See if I can explain it better in wireframe. So essentially, essentially every single piece of this sphere is a polygon mesh, or the whole thing is a mesh, I should say. And it's a bunch of polygons or triangles, depending on how you want to look at it. Polygons just generally for ease of understanding. If you're doing modeling, it's in polygons. Once you throw it into Unity, it becomes tris, but you know, for sake of understanding, let's just go with polygons. So essentially, what we need to do is we need to figure out, like, hey, is this, how do I put this? Is this face going, or is the normal for this face pointing at the light? Essentially, like if we take this table, for instance, which direction of this table is pointing at the light? Or is being hit by the light? Up. We're going up. And essentially what we need to do is we need to figure out, like, hey, if this thing is going up and the light's going down, we have two pieces of pretty good information. Now, how do we do that? So the first thing we want to do is we want to get the normals of the sphere. The normals are something that's baked into the model. I don't want to go too in-depth into it, but essentially if you remember 6N, I guess, there's this thing called the cross product, right-hand rule. Essentially, if you have two edges, you can figure out a plane from those two edges, and then from there you can also figure out a normal vector from those two edges. So essentially that's what's happening in the background with Unity and meshes. So does anyone remember how we get essentially data from the model? What part of this code is data from the model?
The texture? No, the model, vertex.
App data. Vertex is the function. App data is essentially the struct that we're getting from the model. So we want to say, hey, I want to add a float 3. I'm going to request a float 3. That's not a float, that's a float. Float 3, and let's call this normal. And thankfully, Unity has a really nice little thing that just says, hey, this value is going to be the normal from the model. So essentially we said float 3 because the normal is going to be a vector. It's going to be a direction. And then we're saying, hey, fill this normal variable with the normals from the model. And then we're also going to want to do that again down here for the vertex. Normal. Normal. All right, let's see if I can hit the right key. Cool. Perfect. Let's all caps that. Kulalino.
Why do you have to do both?
So the top one is essentially the information that we're getting from the model, and the bottom one, V2F, is essentially what we're saying is where the model is from the camera perspective and what information we need to pass to the fragment shader, which is essentially what pixel is this going to be on screen. So when I'm saying this top one, I'm essentially saying like, hey, model, give me this info. And from this bottom one, it's what info do I need from the model transformed into the camera space and then given to the fragment shader, which will essentially be, hey, what color is this? And because we're essentially darkening like the places that are, I guess, not facing the light as light is to work, we need this in the fragment shader. So now that we have that, we can do something. Well, not something visually yet, but we can do more. So essentially what we now need to do is this normal exists in object space. So essentially it's not quite set up properly for our world. It's not properly set up for Unity. It is all relative to the object center and where the object is pointing. But we need to get it into world space. Thankfully, so this is actually like a bunch of matrix multiplication, a bunch of variables that Unity kind of sets up for us. But the nice thing is that Unity also does something really nice for us, where we just say, what is it, Unity object to world normal, and then I dot normal, or not I dot normal, V dot normal. What exactly is Unity object to world normal? It's essentially doing a bunch of the tough matrix math that we would need to do. This would essentially be like, hey, what direction is this? We need to normalize it. We need to make sure that like we do like inverse and transpose matrix multiplication in order to essentially get the normal from the normal and then put it into the camera. However, Unity realized, hey, you know, you do that a lot, so let's just give you a function for it and it will always work. So with that all done, what we need to do now is I.normal is equal to normalize I.normal. So how many of you know what normalize does explicitly? Because I'm honestly kind of...
Makes it so that its maximum magnitude is 1.
Perfect. That's a much better way of describing it than I was going to do. It makes sure that the maximum magnitude of the vector is 1.
Or I guess just the magnitude, yeah.
Yeah, the magnitude.
Is 1,
yeah.
Yeah.
It essentially makes sure that, like, hey, it's... And when you're working purely off of a direction, you don't really need more than 1. In fact, more than 1 will probably mess you up.
Wait, why do you have to normalize the normal? Shouldn't it already be normalized?
So we're going from essentially...
Oh, because it's in world space?
Yeah, we're going from object space here, and then we're going from essentially world to camera space. And then there's some other thing that happens here. I believe it's some interpolation. We can actually test that, and this is what I'm going to do now, just to prove a point. So if we go back to shaded. Yeah. So this is essentially the normal values shown. So essentially this red is saying like, hey, this is 1 on the x-axis, this is 1 on the y-axis, this is 1 on the z-axis, and this is the exact opposite, so it's going to be dark. The way I did that is I essentially fed I.normal into a float 4, which says, hey, this is going to be a float 4 floating points. I.normal is a float 3, as defined up here.
Just add 1 to the... So let's see, alpha is the dash is the 1.
Yeah, alpha is 1 in this case. Alpha is not really used, but most output wants an alpha, so we have to put it in there. I'm actually curious about what happens if I don't normalize it.
Normalize my magenta.
It looks the same, but I have a sneaking suspicion that it's not actually the same. For safety's sake, let's keep it normalized.
Oh, I didn't uppercase you.
Yeah.
You don't, so you...
Does anyone have any questions so far about what we've done?
If I add underscore time, will it start rotating?
Well, I mean, where are you adding that? But yes, no, kind of.
Didn't work.
All right, I'm gonna make a quick trip around the room and help people if they need help on what they're doing right now. Oh, hey, that works.
I'll just flip the shade.
All right, you go into there. You go.
I was trying to put it make it work. I have to redo it.
Oh no.
Oh, wait, I got it. It's doing rotating.
Material.
I don't need it.
It's a bird.
Put them both. That doesn't seem to.
Oh, it has like a texture too.
Don't worry, I'm still putting in heating.
Okay. Everyone.
Oh, Itai, why can't use these to see the normal?
Oh, I mean,
Well,
that's
I
in the
did that.
deferred render pipeline. So you have to change the camera. So if you go to the main camera and switch that to deferred. Try it now. Maybe? Oh, the animator. Perfect. Yeah.
No, this is not what I imagined.
What?
Yeah, that's kind of why.
At first I thought they would draw lines to show the direction of the normal.
Oh, jeez, Brian, what are you doing?
Add cosine time to before in the normalized
Imagine
function.
that.
Fun. All right. So, how many of you are? What? That's my mouse.
Oh.
You can use it. You're just gonna have to give it back to me afterwards.
I need to. I realized that.
Yeah, you really do need a mouse to work with Unity for the most
So
part.
if you don't normalize the normal, it doesn't seem to change this.
My assumption. So my assumption there, and again, this is working off the cat line. My assumption there is that your normals actually are above 1 in that case, which for the values that are color really won't matter.
You
It's
can't print, huh?
what?
You can't log.
No, no. Your best debug is literally get whatever is your out fragment out.
It's not changing.
You mean just look at it?
Yeah.
Oh, you want the code to change?
I fear for the day when someone asks me, hey, I need you to write these code tests for shaders, because it's like, bruh.
Can you
Does it-
access
does
the
it look right?
magnitude?
Hmm?
Can you access the magnitude of a vector? Like I dot magnitude, is that a thing?
Maybe? Let me check.
Oh, I got magenta.
Yeah.
There's length, not magnitude, but length.
Wait, that's not gonna.
Square root dot, square root.
Oh wait, does that really give you the length of the thing?
Yeah,
Nope.
it gives you a float length, so it's still a 0 to 1.
No, I'm still dumb.
Alright,
It's not working.
so we're gonna move on. Everyone ready to move on? Except for Brian, who's...
Yeah, it's fine. You can go on to that. It's
Boring.
Alright, cool.
Lost it.
Oh, you have sign time.
Yeah, no.
I know that.
So, how many of you... Alright, if we have a vector and it's going this way, and we have another vector and it's going down, how do we want to compare those vectors? Like, what can we do to essentially say, like, because they're perpendicular, or sorry, not perpendicular, because they're going opposite directions, hey, you know, let's say this is a 1. If they're going perpendicular, it's a 0, and if they're going parallel, it's negative 1. There's a very specific linear algebra function used for this, if anyone remembers it. All right.
What was the question?
If we have two vectors
Uh-huh.
and they're going opposite directions,
Yeah.
what math function can we use to essentially get information about that or from that?
What information do you?
Guess.
Are
I
they,
mean, let's say
they're
that you
going
know,
in
they can.
completely opposite directions?
Yeah, but let's also say like this could be
I
variable.
mean, you can find the
like, this
normal
could-
of them, which,
Well, I mean, we already have the normal of the face,
okay.
and say you know, we know which vector light is going in. Like we know what the direction of light is.
Oh, okay. They're not going in opposite directions. They're just going in different directions.
Yeah, let's just say like for the sake of this, like it can go in any direction.
I mean, I know that you can get both a dot product and other thing.
You said other. I don't know what other thing is in this case,
You
but the
said
dot
dot
product is the correct answer. So how many of you are familiar with what the dot product is? All right.
Drawing a bunch
You
of vertical
multiply slanted things and then you add the things.
Adding and multiplying things.
Yeah.
I mean, honestly, I don't remember the equation for dot product. Like, if you ask me, like, hey, what is the equation for dot product, I wouldn't be able to tell you. But specifically, what it gives you is the cosine angle of two vectors. Specifically, it gives it to you in the unit circle notation. So essentially, and it's cosine. So if you are perpendicular, essentially it's 1. Like the angle between two things is 0. So it's 1.
That's why cosine is superior to sine.
I guess. I mean, you could do this in sine. It's just going to be like you're going to have to add 90 degrees. If you're perpendicular, that means there's a 90-degree angle, so you're sitting at 0. And if you're 180 degrees, it means you're sitting at -1. So what we can do is we can essentially say like, hey, you know, float 4 dot float 3, and let's just say 0, 0, and let's take it on the z, I dot 1. I have a feeling that that's going to return a float 1, but yeah, it's a float 1. Hold on. 0, 0. So it should just be red. Yeah, there we go. So essentially, I'm going to pull that back up. So if I take the dot product of float 0, 0, 1, essentially what I'm saying is, hey, I have a vector on the z, and it's 1. What direction, like how large that vector is, actually doesn't really matter, to be honest. It's just the direction that it's in. And we can kind of change this to whatever we want. Like, you know, let's say if we want a y.
And I'm pretty sure you don't need to normalize it.
You know.
There's probably a reason, I just can't figure it out.
What the heck? Where's the token whatever? I can't see it. Ah! There's too many fucking dots on this monitor. Ah! There we go.
Wait, I missed that.
Well, there's too many dots on this monitor. I can barely see my commas. Oh gosh, we need to replace this TV so badly. But essentially, I'm taking the dot product now of the normals and the y vector, so y up. So with that, I think that we kind of have a way of getting lighter. I see a lot of confused faces right now. Well, I see O'Brien frantically looking back and forth.
What do these numbers mean?
Okay, so
Okay.
you're doing the dot product between the normal and then the y vector floating up. That's float 0, 1, 0, right?
Yeah.
And that gives you one value, so that's being used as our red channel. And then 0, 0, 1 is just, okay.
Yeah, GBA.
Yeah.
Yeah. So that's essentially saying like, hey, dot always returns one value, the angle, and then that would be R.
So the angle between the normal vector and the upwards y vector is being displayed as the red channel of our shader.
Yeah.
What if we don't want red?
Oh, I have it.
We can replace it. Here, I'm gonna walk around and help people again.
Multiply together, divide by 0, let's multiply together.
That's a comma there.
Find on that we get.
And an extra comma there.
So
Oh,
let's do
it's
the whole thing.
The goddamn TV screen.
Okay, yeah. we need to stop with this TV screen.
Huh?
So 0 again, and that should work.
We need a new TV.
Whoa.
Hold on, try it again.
Brian, what's that?
Don't worry about it.
See now. I do not see.
Switch back.
It's a thing.
Flout. You misspelled float.
Oh.
Make it say Brian.
It's 0, 1, 0.
Incorrect number of arguments.
It's inside the dot product.
What do they do? Why does it not work?
It's float 3, 0, 1, 0.
There needs to be a comma between that brown or that.
Which one way?
I don't know. I just want to remove
Ow.
Where's the
that.
light? That float 3 does.
Yeah, and that float 3 probably needs to be a proper vector because right now it's just nothing.
Why
So like
does
just
that
put a
have-
1 anywhere in there.
How happens if you have 1, 1, 1?
It's gonna be on like a diagonal.
What is this dot product again? Okay, so it's where, is it where the light's coming from?
Yeah, so it's essentially the vector that light is coming down at.
Oh, no
Okay,
way.
So
Wait.
it's
Change the
not
position
based
of the light.
on.
Yeah, it's not.
Oh,
It's
this
not
is
based on the light yet.
Please work.
Oh.
It's not.
So it
Not
does
yet.
it does
Three.
returns.
It returns between -1 and 1.
I got it to
Which
spin.
means
So -1.
I need to spin.
Oh no, it's not
Okay,
spinning. It's
so
not spinning.
-1. Do you know the unit circle?
I replaced the upward
Okay.
y float with just
It's
cosine
okay.
time
So
because apparently underscore cosine time has
-1
multiple
essentially
values
says
in it,
that
which is
the
now
two
treating as a
vectors are
vector.
parallel. They're going in the same direction.
Good
0 says they're perpendicular,
del.
and then 1 says that essentially they're going opposite directions.
Yeah, that's instead of the
essentially
float.
the
That's
idea
instead of
is
the
that
upward
like
float.
if I have
if
I just
kind of
replaced it
hands
as
or
a
arrows.
for cosine theta.
If we're going like
That
this,
oscillates.
the dot
So
product is getting
You're
this
changing the direction that the
and giving
light
it
is coming
in
from, basically.
1 to negative 1. And then from that, we can essentially say like, well, this is 0.
It's not oscillating.
0 angle,
It's interesting that it's a
which
vector.
will give us a 1 in cosine.
Did you put it?
Yeah, it's kind of wacky.
So what it actually does is we multiply these two together and divide by their lengths plus together and put the arc offset on that and get the.
Yes, I guess.
Let me see.
Though you don't want to do length, it's probably like if I go into the
Why does it
documentation
look like
for it,
that?
it's not quite the same.
Oh.
But essentially it will
Right.
do the same thing as what you just said. Trust that it's more efficient than that.
Why'd you set the blue to 1?
Alright. While y'all are doing that,
I mean, that's all I did. Look forward. It moves kind of slowly. So look at it again. Is it moving? Mine's definitely moving.
I'm gonna pull up the unit circle.
Why is time changing
So
while
it's
the
just
game
the
isn't
cosine
playing?
value of the angle, right?
It's kind of interesting.
Not unity circle, unit circle.
I
Yeah,
don't know.
so if you've ever seen
God.
this,
Oh, I remember this.
yeah,
Oh,
this is finally useful for something. Finally, because this is the angle thing that makes dot product work. So like here we have like a vector going this way and we have a vector going this way.
All the time.
So cosine theta is 0, which means if we pass it to, I wish this was bigger. That's a 1. Cosine theta at 0 is equal to 1.
So it's the x value of the circle.
Yeah.
And 0 starts on the right.
N-
The angle of 0 is on the right.
And then this would be 0, so perpendicular angle. And then this would be -1 when they're parallel. So this is finally useful. I learned this in high school and I hated it and I didn't understand it, but this is useful.
I use that all the time, you guys.
Stop
It's
it.
my favorite.
Stop it.
Wow.
All right. So now that we have that, there is a thing though that we need to be careful of, is that essentially this can get us a result that is -1, and we want our shadows to just be black. And I'm gonna fix this later once we actually have shadows. So here's the fun thing about Unity is that it doesn't really give you access to the lighting from in here without an extra include file. So we're gonna replace Unity CG include with Unity standard BRDF. Hopefully that's not gonna destroy everything. Cool. Essentially this is if unity.cginc. This is essentially a include folder or include file that handles Unity's lighting stuff and passing the lighting to the shader for you. And it is derived, or it includes unity.cg or Unity CG anyway. So everything in Unity CG is in Unity standard BRDF. So you don't really need to worry about it too much.
What was it called?
Unity.
Standard BRDF.
Yeah.
Unity standard.
Can I zoom in?
Right direction.
Yeah, case matters a lot. BRDF. Binary. Not binary. What am I saying? Bidirectional reflectance distribution function. Oh, that's a mouthful.
I didn't
Birth.
realize there was nothing break.
Dot. Do you still have unity.cg or Unity CG?
Oh, wait, let me try coming to this. What if I break there?
Wait, are you putting
Well, you're
debug
not
breaks?
using it yet, so I don't know that it's testing it.
Because
Alright.
I removed some.
Alright. So, the nice thing about this is that this defines a neat little value called underscore world, is that capital? Yeah. Space light pose 0. So this essentially is where the light is, or it's more correctly the direction that the light is facing. Because especially with a directional light, that's kind of the only thing you need to care about. In Unity, a directional light is essentially a vector. It's a singular vector that points in a direction and everything pulls from it. So what this does is that gets us the vector, x, y, z, And what we can do is we can actually take the dot product of that. So, and the I dot normal, and bop. Let's make sure everything's right here.
Mine worked without specifying .xyz. Does that mean that it's like got extra information it's using?
It does have a, where's the directional light? It should have an A in there somewhere, like an alpha value. So,
Cool.
whew. Yeah, so now our lighting follows through, which is super duper nice. So yeah, that's nice still. The problem is though that if we, so here's the micro problem with it, and this is just to show an example, is that those back faces that are not facing the light are technically valued at -1. We want it to be 0. It really doesn't make much sense to have it be -1. Like, that's just going to cause us math errors down the road, probably. And to showcase this, if I do a +1, oh, huh. Fun, actually. That should not be that. That's fun. Why is that work? That should not work. That should be -1.
Well, the black back is still black.
Yeah.
Which if you added one,
Oh, I
wouldn't
didn't
make any
save.
sense.
Yeah. That's what I'm wondering myself, actually.
So yeah, because it's black on the bottom. That makes sense.
Yeah. Yeah, it's 0.
Where'd you do that leaf texture?
But yeah.
It's a brick.
Oh, I had a brain fart.
Get in there.
Sorry.
How do you find it? Where'd you find it?
If we add 2 and then divide it by 1, or multiply by -1.
Like this brick.
Well, it makes sense that when you add 1, the bottom is still black, because that's the -1 part being
Yeah.
now 0.
Yeah.
Because otherwise, if it goes from 1 to 0 and you added 1, it should all be red.
Yeah. But yeah, so in order to fix this, we're going to use a function called saturate. And what saturate does is it essentially says, hey, if you're below 0, just go to 0, and if you're above 1, just go to 1. And I'm going to save this as a value because fixed 3, or lighting normal. Or let's just do a fixed 1. Is equal to saturate. Let's just
Correct number of purples. Wait, isn't that a float?
But so let's do lighting normal. Is that what I called it?
Yeah, that should be a float.
So fun fact, yeah, it should be a float.
Fixed.
That's an actual data type.
Oh, is that just like fixed 1?
What about fixed 4? Fixed 3?
So fixed essentially is, hold on, can I do fixed here? I feel like I should be able to do fixed here. Yeah, fixed works. Fixed is essentially an alias for, or not an alias, but it's essentially a wrapper around floating point number values, because on mobile you're not going to have so much floating point precision. So you're going to want to use a data type called half. If a float is an 8-byte floating point integer, a half is a 4-byte floating point integer. And essentially, fixed is a wrapper that says, hey, use whatever the computer can give you. So generally, we like to write in fixed, although honestly, I don't really write stuff for mobile all that often, so I usually just go with a float. So, another thing about this is that I have a feeling, okay, well, surprisingly, that's playing nice. So this is another thing with the Unity tag. First of all, has everyone gotten this to work properly? Cool. So this is the thing with the Unity tag system, is that you do need to tell Unity what kind of light mode you're in. Essentially like, hey, how are you taking the light and how are you adding it? I've seen some weird funkiness. I remember when I was demonstrating this whole demo for 2 people. Essentially, oof. I remember this now. It completely disappeared on me. And I remember doing this during the demo and finding it very bizarro. What happened? Was it light mode or light mode?
It didn't do anything.
Forward.
Yeah.
I think I made that error twice. Like literally, I was doing this by myself and I was following something and I was like, forward base, and it disappeared on me and I was like, what did I do wrong? Like what happened? But yeah, so here we go. Now we can keep moving on. And hey, you know, let's do something just very simple. Let's say, you know, let's multiply our color by this lighting normal. So if we said, hey, you know, get rid of those, and did col times the lighting normal, we'll get, fun. What's going on here? Oh, that's a fixed 4, so I don't even need that. Yeah, so now we have our texture, and we have our dark areas. That's because essentially this lighting normal is essentially just very light, it's almost white where the light is facing us, and it's dark where it's not. And by multiplying 1 by our color, we get our color. So essentially this is like a nice little fade to black on our texture. Our very, very dense wood texture. So yeah.
I don't have a texture, hang on.
Yeah, I should have asked if people had textures.
What's the end of the saturate line?
Oh, it's the dot product between our world space light position and our normal. Yeah, so I just wanted to save that value because it's going to become important.
Okay, wait, but the back is like completely black.
Yeah, so we're going to be fixing that. So we can also get light color from that light value, and it's literally just underscore light color. It is, let's do a float 3. Or you know what, I'm already in float land. Float light color is equal to underscore, what is it, light color 0.rgb. So this essentially gives us the color of the light. And if I just throw this in here, we'll see it, we'll know it, we'll feel it. And Puchow, Kerchang, bada boom. So yeah, light color 0.rgb is something that's in our include file. It essentially is the lighting value from the main light that we are being hit by.
You can't just multiply 2 colors together each time.
What? I mean, you can though.
But it turned it magenta.
Kerchow.
Okay, it is normal.
And let's just make it diffuse. So float 3, diffuse. This is just for math reasons, I guess.
Still diffuse wrong.
So what was the lighting normal?
Hmm?
You're not returning that,
Oh.
you're not returning that lighting normal, right? Or did you?
Lighting normals still here.
You're not returning it though?
I'm not returning it anymore.
He was just showing the light color, that's why.
I'm gonna from now on essentially return diffuse. And maybe change it once or twice, but most of that should stay the same. So let's just say light color times lighting normal. And essentially we should now have something that multiplies our light color. Yeah, and we're gonna wanna keep that diffuse. So what we can do now is we can probably say a times our color dot RGB.
Oh, that's interesting.
And we now can tint based on the light color everything.
Must have been. Maybe one of them doesn't have 4 values. Or something. That's why mine broke before.
But yeah,
They're just doing the wrong order.
we are running out of time.
Confused. Yeah, now it's.
I'm having a problem.
What's your problem?
I'm trying to find out.
Wow.
We might have to break this into 2 workshops because I am strictly running out of time here. Like, actually, I didn't think I would, but.
It
You
says
put the VGTC
incorrect number of
shadow
arguments
yeah,
of
it's
numeric
a
type
shadow
of
ball.
structure. You got it. It says the
Oh.
You need the headlight code shadow ball.
Whoa.
There we go. This is an ugly texture.
Eh, it's fine. Textures are
Headlight coding.
I mean, I'm pulling all of this from Cat
It's so cool. See the shadow ball.
It's the shadow ball. No shadow ball. Everyone got their stuff going? Yes. So 3, lighting normal, just replace that with diffuse, and the last value should be 1. Light normal, lighting normal. There we go. Yeah. You should be able to change the color of that. And that's essentially how we want to do basic light stuff. So this is kind of off the tutorial, but I'm not the biggest fan of how dark this is. In most games, you're going to have ambient light, and this is kind of off the tutorial, just purely speaking on the fact that, like, hey, we have 15 minutes left. It's been an hour, and we already got shadows in. We can do the specular highlight next week, and I'm totally not padding for content. Hey. But essentially what we can do is we can say, like, hey, you know, this is really dark, so let's have, like, I don't know, let's just make a float 3 ambient. And ambient is going to be some color, so let's just say underscore color. I'll set that up later. Times lighting normal. Oh. Let's do times -1 plus 1.
What is happening? What? Why?
So if we have 1 and 0, what happens if we subtract 1 from that? Or actually, hold on, I did that
Did you just do
poorly.
1 minus?
Yeah, no, I did that poorly. Yeah, my bad. I'm a dummy. That essentially is how you invert a mask. You -1 from everything. This will take the bright parts up to, down to 0, and it will take the dark parts down to -1, and then once we multiply -1 by -1, we get 1. So it's essentially a flip on the mask. Which, yeah, so I didn't add color as a value, so I'm going to add it in properties. Underscore color, color is equal to 1111, and
Should it be
then,
capitalized?
nah, who gives a flying pertwee? So that will give us this, and, oh right, need to add it.
You spelled ambient wrong.
Ambient.
Oh, you're adding them.
Yeah, I'm just adding them.
Ah!
Yeah.
Could you go back to see what you added?
Yeah.
Oh, I see. So you're
At the
inverting
very
it
top.
at the
In properties.
What?
In properties.
Oh.
interesting.
Is color.
Yeah, I'm essentially inverting the mask and adding that red color to the inverted mask. I'm also
Like,
gonna.
real bright.
Yeah, it's a little bit much. It's a little bit bright. You can darken it manually. You can also just generally say, like, hey, you know, I think that Unity does have a. I want to say that Unity actually has an ambient lighting.
Plus, that's not showing the texture anymore. It's just a solid color.
Yeah, I know.
Should you do something else with this? Oh wait, huh.
Can you also just add like 0.1 before you saturate the normal? You know what I mean?
Add 0.1 before you saturate the normal?
Yeah, so that makes, well, that's kind of dumb, never mind. That just like extends the range of the light so that it's 1 for more of the space.
Sorry, I'm looking through light attend, light matrix, world space light color, unity light color, colors of the first 4 non-important point lights, world shadow, light colors, light color. Alright, I guess they don't have an ambient.
Oh, you still say that I have an unidentified underscore color.
Spherical harmonics used by fog and ambient. Unity ambient sky. Haha. Knew it existed. So we can take that and probably say, hey, give me the ambient sky. So that's kind of getting the color from the sky, and it's kind of just brightening the whole thing. So let's just do this. And then that part should be a little bit darker.
What is the code for the sky?
The sky is Unity Ambient Sky. So this is a predefined value, and I think window, rendering, lighting settings.
Wow, that was black.
That's weird.
Do color. I want to say I should be able to change. Yeah, there we go.
Yeah.
Yeah, so Unity will generally pull its skybox value from something. Usually it's the default skybox texture. That's weird that it's like now got like this, you know. Yeah. That's interesting that it's stuck. That shouldn't be stuck. That's so dumb. Why is it stuck? Why? Okay, hello, Mark. Gradient? Can I actually gradient this? What's gonna happen if I gradient this? Okay, nothing. Fine.
How do you enter lighting?
So I am well acquainted with that menu. So you go to Window, Rendering, Light Settings.
Lighting
Yeah. So that's kind of all we actually have time for today. We've got maybe about 7 more minutes. So I'm just going to spend those 7 minutes essentially answering questions. And next week we're going to get on to specular highlights and smoothness, which is the little very bright point in the texture.
What is a Blinn Phong? Real quick, I think I may have
What is a
done.
Blinn Phong?
Blinn Phong? Okay, so Blinn Phong is a... Oh, wow, I actually didn't answer that question. Blinn Phong is what is called a... What is the term? What is the term? What is the term? It is a modified Phong reflection model. What's the term? It's a BRDF. Forget what BRDF stands for, though. Blinn Phong is essentially, so there's a Blinn Phong is essentially how do we calculate, given a normal and given a light, how do we calculate how that light affects the model? And it's very computationally effective. It's pretty cheap to do. And the idea is essentially, Blinn is one way of doing it, Phong is another way of doing it. Someone was like, well, I don't like the result from Blinn, and I don't really like the result from Phong, so we made Blinn Phong. And they just kind of peanut butter and jammed it, and it's like, oh, this actually gets me kind of nice results. Like, if I remember correctly, Blinn has like a different specular highlight, which we didn't get to today, sadly. Yeah, see, this is Blinn Phong, and this is just Phong, and the specular highlight on Phong is kind of really sharp, intense, and it's kind of overall brighter. Whereas this Blinn Phong, you know, darker darks, larger lights. Although we can and do have more control over it. So, and it's also pretty efficient. If you want to see the code for it outside of Unity, here it be. So yeah. Any other questions? Any questions about the math we did today? We kind of took a giant... Honestly, if I had to do the entire normal calculation stuff, I would have been pretty angry. That stuff is like really long. You're transposing matrices in order to get the things you need, and I'm like, blech, no, please. Luckily, CG has a transpose function, so it's relatively fast, and an inverse function, so it's relatively fast. It's just a lot to write.
Talking about the Unity object to world normal? Or-
Yeah, Unity object to world normal.
Yeah. I have no idea what that even does.
Essentially, it takes the object normal and puts it into world space normals.
So the normal value you get is actually in object space.
Yeah. Were you here for the first few workshops? Okay, so essentially, when you have a 3D model, it exists in 3 different spaces. It exists in object space, world space,
Screen space.
yeah, and screen space. The idea being that, you know, each vertice on an object has a position, and when you're doing a 3D model, it's like, well, this is relative to its pivot point. But then once you throw it into Unity, it's like, well, not everything can be relative to your pivot point, dude. That's not how that works. So we have to then transform it into the world space. We have to say, where is this vertice in world space relative to 0, 0 in the world? And then we need to do a transformation from world into camera. Essentially saying like, hey, take this 3-dimensional object and transform it into a 2-dimensional plane that we can stick on the screen for you to look at.
And we need the world space to have it interact with the light color 0 thing.
Yeah.
If you have 2 different lighting sources, does light color 0 still work, or is that just the first light source?
So it's probably, you can do light color 1. However, what you actually probably are going to have to do is you're going to have to do another pass. And a pass essentially through your entire lighting pipeline, but under the tag of forward add and not forward base. What this will do is it'll essentially say like, every single lighting source that you are pulling from, you're doing another draw call that adds to your original draw
Oh,
call.
that's freaking weird.
Yeah.
So you render like twice.
Does that mean that every lighting source like doubles
Yeah.
your draw calls?
Yeah. Every this is something that I've been screaming at people about, is every time you add a light in your scene, you essentially create so many more draw calls.
What if they're all
Jesse,
static?
I know you're winking or you're grinning back there. There's a reason why I was like, oh, gross, dynamic lights. But you know, if they're yeah. So the nice thing about static lights is that you can bake static lights, or you can bake portions of the static light.
How do you interact with the baked information inside of a shader?
That's a cat-like coding tutorial for another day.
Okay.
So speaking very honestly, I was doing Blinn Phong because of the math. I'm not doing Blinn Phong because I think this is a good way for you to interact with lighting in Unity. Speaking pretty objectively, if I were to interact with lighting in Unity and I needed to build a shader that interacted with light in Unity, such as like, hey, reflection maps, lights, light probes, everything, surface shaders do that for you. It literally handles all of that for you. So in most cases, if you're making a shader that requires light interaction, you really just want to do a standard surface shader, and it really makes your life easier. But if you ever want that standard surface shader to say, have like a wacky shadow or like a non-standard, like non-realistic looking shadow, then you really want to do vertex stuff, and then you might have to rewrite everything, but hey, at least you get your really nice shadow.
Can we use Blinn Phong to make a toon shader?
So the fun thing about toon shaders actually is that what a toon shader is it's just a really sharp edge on this lighting. So like, if I go here and I essentially say, you know, lighting normal, saturate, if I do step and say 0.5, right? That's kind of what a toon shader actually is. A toon
But the
shader,
texture still shows up.
yeah. A toon shader is essentially an outline and a really sharp shadow. And the way you usually want to do that is via step or smooth step. Step is essentially, hey, if it's over this, set it to 0. If it's under this, if it's under this, set it to 0. If it's over this, set it to 1. And that's how we get that really sharp line. Smooth step introduces a bit of a nice kind of almost a lerp between the 0 and 1. Whereas lerp is diagonal, smooth step is kind of more, I guess the term is quadratic, I guess. Or not quadratic. Yeah, kind of quadratic. Essentially, it's a smoother slope. And that's how you can kind of get toon shading.
it just smooth step camel case?
I think it's smooth step all lowercase actually, if I remember correctly. Let me see. I'm gonna head out soon.
It's not working. Yeah, okay.
Yeah, it's all lowercase. Let's see,
Does it
like,
take different parameters?
yeah, it does
Oh,
actually.
that's why, okay.
Yeah, it's,
How much?
Oh, that's interesting.
yeah. So like this is 0.3, and then out here is probably like 0.5. So it's kind of like this is the range where I want it to transition, and that's how smooth step works. So
Could you get it to do like multiple steps with like a regular step? You know what I mean?
You can do multi-banded stepping.
Yeah.
I don't know how to do that off the top of my head. And generally, the thing about doing multi-banded stepping is that you are limited at some point. At that point, you kind of just want to do a lookup texture instead. Because essentially what a lookup texture is like, hey, like, you know, multiply so-and-so value plus this, and essentially getting it to either be 1 or 0. And based on that, you can essentially feed it different lookup textures that will get you different tune lightings as you need it.
You can also do floor, right? Like multiply by a value floor and
Yeah.
divide by that value.
Yeah, you could do that too. I usually use round instead of floor.
Oh, really?
Yeah, see, floor,
Ooh.
floor's nice, but
It's so pretty.
yeah, you do that really fast. What the hell?
Oh.
What the heck, Brian?
Well, you just add round and then you multiply by 3 and divide by 3.
I'm ending the stream. All right, yeah, I'm gonna end the stream. Do, 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 do.